So this is one of the skills you'll need for the B part of probability, okay? And it's this binomial formula where these two numbers always match and these two numbers have to add up to this. All right, so we've practiced those. If you want to see more about those, we've got a whole video on it. That's one of my previous videos. But let's do a CC over C, and here's a sophomores and freshmen question. Raise your hand if you're a freshman right now. And hands down. How about sophomores? There's less sophomores, so I'm going to count those. Keep your hand up for sophomores. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there's 9 softs, so put SOP for sophomore, and there's 9 of them. And I'm going to count how many total we have. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 27 of you total today. 27 total. You should know where that goes. And this is frosh, as in freshman. And you should be able to figure out that too. Now, I haven't told you how many I'm taking. Since there's more freshmen in this hour, to be able to best represent the class, if I had a little focus group that I was going to ask, like, hey, are my lessons going too long? Or, you know, how could I make my class better? I'm going to pick 3 freshmen and 2 softs. Now, right now, so far, if I just asked you how many ways can I do that, then I don't need a CC over C. If I just ask how many different groups I could pick, then I'm going to take out this C. Why? What is it missing that means I don't need to divide by C? Yeah, it's not a probability. See, this is when you use a CC as if it's not a probability. Now, how could I make it a probability question? We'll do that in a second. First, let's just start with the what CCs did you set up? Talk to the kid next to you. All right, you guys knew this was 18 because you knew that the 9 and the 18 had to add up to 27, so that was good. And you knew you were picking 3 freshmen, so this is a 3 and this is a 2, and that's pretty easy. And you always times these. Some kids on the test added them. Those are both how many choices you have. So you always multiply choices. All right. And then the reason you divide it would be if I said it this way. If I said, I'm picking out 5 kids randomly, what's the probability I'll get 3 freshmen and 2 sophomores? See, if I pick out 5 kids randomly, then it's 5 kids are being chosen out of the 27. And now it's a probability that it turns out this is what I want. Instead of it's going to be that way, it's what I want to happen. And if by randomly picking 5 kids, it's nearly as likely. All right, and the last scary part is that even having all of that right, some kids got the wrong answer on the test. How would they have all of that right and then the wrong decimal? It's because they didn't realize you have to have parentheses here to get the whole top done first before you divide by the bottom. Okay, so I'd like you to type this in and make sure you get the same answer as the kid next to you. And hopefully, well, at least one of you use the parentheses so you know that you're doing it right. You see, otherwise kids tend to just trust their answer. How do you calculate? It must be right. Bryn, you better finish, just to make sure. 8 and C.
Oh, yeah.
Did you check with the kid next to you?
Yeah.
Did you guys get the same thing?
Yeah.
And what'd you get? 3.361. Can anybody verify? 361. Oh, 364, I heard him wrong. 364, raise your hand if you had 364. Okay, good. All right, if you didn't have .364, then maybe you're not typing these in right, and you should talk to me about that. All right, so next up, when would you ever use a P? Can you give me a scenario for 10P3? We've done tons of things with C's, not that many with P's. So I know you know how to type this in on a calculator, at least I really hope you do. But the question really is, what kind of a problem would you use this on? Let me just ask it this way. Talk to the kid next to you. Could this be about a race? Talk to the kid next to you. Bottom line, yes. It could be about a race because the order matters in a race. So if I just said, hey, you, and you, I picked 3 kids. Could you guys go out in the hall for a second? Do you think that the order is implied that the order matters in that situation? No, it's just picking 3. Then I'd use a C. All right, so this is about P is when the order matters. Order matters. All right, trying to connect order mattering with the P. All right, so could this be done with 3 blanks? I'm picking the 3 kids to go out in the hall. Well, that'd be a C question. How about the race? Could the race be done with the blanks? I'd like you to do this on a calculator, and then I'd like you to try it with blanks, and I'd like you to see if they get the same answer. This is how many different ways kids could finish first, second, and third when there's 10 kids racing across a parking lot. Make sure you know how to put in to MP3. And then make sure that you know how to do it with blanks. And they're either going to come out the same, or they're going to come out different. Get both answers. Be prepared to talk about it. All right, so you should have got the same answer, first of all. All right, Mr. Breen, what was the answer? 720. So there's 720 ways that they could finish first, second, and third, and the order matters. Bob being first is different than Bob being second, for example. All right, and then this would be done by doing, there were 10 choices for first place, 9 choices for second place, and 8 choices for third place. You with me on that kind? All right, they both would come out to 720. So does that mean you can always use blanks or P's? No. The blanks are better because the blanks can be flexible this way. In a real race, you could look at the group of 10 people and there might be this one kid that's like, oh, I know he's on the track team. I know he's actually like state track sprinter. He's probably going to win. And all of a sudden, this isn't 10 choices for first place anymore. If I knew he was going to win, there would only be 1 choice for first place. You get what I'm saying? All right, so let's do blanks for a password on a safe. So let's say that your parents just bought a safe and they're like trying to decide what password to use. You can use numbers or letters for every spot. But you guys talk about it and you decide that Q, the way that the Q appears on the screen looks a lot like a 0. And so you don't want to be confused with your password on whether it's a Q or a 0 on the screen. So you decide to throw out both Qs and 0s. And your dad is of Chinese descent, and he personally loves the number 8. So he wants the password to start with an 8. See, 8 is a lucky number in China. Last thing, in Chinese, when you say the word 4, it's a lot like the word death. Not kidding. Can anybody verify that if you do know what I'm talking about? Yes, somebody's nodding their head vigorously. This is true. Number 4, when said in Chinese, sounds like death, and so they really don't like the number 4. It's kind of like unlucky. So here's the final thing. How many passwords could you make if you can't use 4s because they sound like death? You got to start with an 8. You can't use Q's. You can't use O's. Because Q's and O's kind of look alike. Can't use Q's, O's, or zeros. Here's all the things you can't use. No Q, no O, no 0, no 4s. And you must start with an 8. How many different passwords can you make? Are there any other things I said you couldn't use or did you had to use? All right, I'm pretty sure I got all of the no's. All right, last hour, many kids got this wrong because they were not thinking about how many choices you would have for each spot. Pretty much everybody knew to multiply them together, but they get confused on what numbers to multiply. So talk to the kid next to you. What are your 3 numbers? All right, Max, what did you say the first number of choices was? Wait, the first was 1. Yep, because you had to pick an 8, and there's only one choice. And how about the next one? Normally it'd be 36. There's 36 different things you could pick from, but we couldn't take 1, 2, 3, 4 things, so that would be a 32. Did I say numbers could repeat? Did I say anything about repeating? Okay, then they can repeat. So then it would be 30, take away the 4, 32. What if I had said, oh, by the way, numbers or letters can't repeat? Then there'd only be 31 choices because we already have an 8 here, but we didn't throw in that repeat thing. So if you said 32, raise your hand. You were right. Good. And then the last one, if they can repeat, wouldn't it be 32 again? All right, good. Do you get why this would have been a 31 and this would have been a 30 if you can't repeat things? All right. Okay, what if you had blanks over blanks? Is that even possible? Could that ever happen? Yes. Let's say I said, it's just a 3-digit number, like 987, okay? It's a 3-digit number. If I just pick a random 3-digit number, what's the probability it's 900 or bigger? I'm going to say that again. If I pick a random 3-digit number like this, what's the probability that it is 900 or bigger? So you got to think, how many choices do I have? These are all the possible ones, and this is what I want. I want it to be 900 or bigger. All right. Don't even multiply it all out. Just figure out what your choices are. How many choices do you have for that first number? And then what's possible, that's the bigger answer, is always on the bottom. Now I'm just trying to get a feeling here. How many of you feel confident in your answer? All right. Okay. So now, if the other person has a different answer than you, talk them through it. Okay? Talk to the other person. Carlos, how many choices on the bottom did we have for these numbers? Did you go up 10 times 10 times 10? All right. So that's a 1 with 3 zeros, which is 1,000, right? All right. And then on the top, there was only one choice for this first number. It had to be a 9. Only one choice. And then there's 10 choices for this and 10 choices for that. All right. Now, you can probably do this pretty quick if you go, that cancels and that cancels. So it's 110. 1 in 10. There's a 10% chance or a 0.1 probability. Get how I could do it faster than by canceling stuff? Because these are being times. And then if things are being times with each other, then you can cancel. All right. So there's one more kind of question that really gets people, and it's the insurance questions. Those are expected values. So let's talk about expected value. See, some things you can buy insurance for it, but you don't have to. A lot of things you have to buy by law or because you have a loan. Like if you have a loan for your house, do you get that the insurance company, the bank that borrowed the money from, they really want you to insure it because otherwise if it burns down, they don't get their money back, right? So they require you to have insurance on your house until it's paid off. So let's imagine that your house is paid off. All right. Now you have a choice. You can buy insurance for it or not. And this is actually a real situation. Some of you may not know this, but I actually have an insurance company or it's an insurance agency that I had it for now for like 30 years. And so we insure people's houses, for example. And so some people have decided I'm not paying for the insurance because it's so expensive. You can imagine, like if you own a house that's worth $300,000, but it's going to cost you $8,000 for your insurance because your house is kind of old and it's got a wood-burning stove, which increases the chances it's going to burn down one day because you always are having fires in the fireplace. And so you have this $8,000 insurance and you don't want to pay it. Then the question becomes, what's the expected value of this insurance policy? So here's the numbers. It's $400,000. That's what the insurance company would pay out if your house burned down. And the insurance costs $8,000. And what you don't know right this second is the probability of your house burning down. You can't answer this question because I didn't tell you the probability of your house burning down. So I just want you to start with the expected value. There's a formula for it, and you're supposed to know it, and it involves P and A, but it isn't just P times A. Talk to the kid next to you about what you need to do. All right. It is P times A, but it's not divided by something. I heard some people say that. It's P times A, and then, Henry, can you tell me the rest of the formula?
Plus P times A, and then minus the cost.
And you keep doing that until you're done, and then you're right, minus the cost at the end. You got to figure out, if you don't factor in the fact that it costs $8,000 to buy the insurance, then you're not figuring out the real expected value. Okay, now let's say that the probability that your house actually burns down and you needed the insurance is only a 1 in 100 chance. 1 in 100 chance that your house burns down. Now, what's the expected value of the insurance? Now, some kids are just going to go 1 in 100 times this, but you got to do both things that could happen. You got to do the P times A and another P times A if you know what you're doing. So good. The insurance is going to pay you $400,000 to rebuild your house if it burns down. Of course, the other bigger probability is that it won't burn down. All right. So, what's the probability it burns times the amount you get if it burns? And this is not burning. And we're going to add it all up. And then at the end, we're going to subtract the cost. All right. The probability it burns, 1 in 100, times the amount you get, 400,000. Somebody do that. What did it come out to? 4,000. Probability it does not burn. The key to that is, even though the probability is really high, it's not going to burn. The amount you get is 0. So then I know it's going to come out to 0. Even if it was 99 out of 100, you still times it by 0, you get 0. So that's 4,000 minus the cost. And it equals negative 4,000. Raise your hand if you had that one right. Cool. Do you see why some people might say, it's not worth it? But the scary part is, if your house does burn down, you just get like a, gee, that's really sad. You don't get any money. And you got to come up with the 400,000 for your house. So if you were really rich, they'd be fine. You could take that risk. But unless you're really rich, it's really scary to take that risk. There's also more that insurance gives you that people don't know. Like, for example, if you are playing golf and you bean the person in front of you with a golf ball, there's something called you are liable for that because you hit them. You shouldn't have hit the ball when they were right in front of you, but you didn't see them, they get hurt. Then there's liability, and a lot of times insurance will cover your liability. So they'll write a check to the dude because he had to go to the hospital and stuff. And so insurance covers more than just your house burning down, is my point. Okay. And again, it depends on the policy in Minnesota, et cetera, et cetera. All right. So one last one is a warranty question. A warranty is basically insurance. So here's the scenario. $4,000 TV set. And you're like, dang, if that thing breaks, this is going to suck. And so you're tempted by the $200 warranty because you got a toddler. This is a real situation in that a lot of people have some toddler who's more likely to break a TV than an average family would because they chuck like little cars around and they don't know what they're doing. And so, yeah, you might want to buy the warranty. Well, let's say, including the fact that you have a toddler running around your house, the probability of breaking the TV is 1 in 25. What is your expected value for buying the warranty? So really, when you have an advantage over the insurance company, because you know I am far more likely to break my TV than the insurance company thinks, then you might want to buy the warranty. Because they don't know you have a toddler. Or maybe the warranty would cover theft. And maybe you live in a really bad neighborhood where your house has been broken into 3 times already. They know, you know that, but the insurance company doesn't know that. All right. That's why insurance companies ask a lot of questions nowadays. Like, if you want to get an insurance quote, you got to tell them so much stuff. For sure, you got to tell them where you live because it makes a difference. If you live in a neighborhood that's very safe versus not, they charge you different amounts. All right. You should have done 2 probabilities. Probability that it works and breaks. And then for that scenario, you do the P times A and the P times the A. And here's a classic mistake. Everything's gonna be right except for one little thing. 1 in 25 chance that it works, and you get nothing if it works, so that's equal to 0. And then there's a, nope, I just did it backwards, and that's the classic mistake. There isn't a 24 in 25 chance that it breaks. All right, so I have these two reversed. There's a 24 in 25 chance that you get nothing. And there's a 1 in 25 chance that you get $200. And so that, I can do this in my head. I think it's 8, isn't it? Is that right? What is 200 divided by 25? 98% sure I'm right. Yes. Add them together. This warranty is only worth $8. No, wait, I did something wrong. It's a $4,000 TV. You don't get $200 if it breaks. It's a $4,000 TV. You get $4,000 if it breaks. It's now worth way more than $8. I knew something was wrong there. Okay. So, what is 4,000 divided by 25?
4,000 divided by
160.
160.
It's worth 160, and the classic mistake would be to say that the expected value is 160. Problem is, what did I forget? I forgot to subtract the cost. So it's actually negative 40. Is that normal? Yeah, it's kind of normal. You're going to lose money on average if you buy a warranty. But you have peace of mind. If that you have a toddler running around the house or whatever, you have this extra chance that it's going to break. All right. So now you have a fair amount of time. And today, I think what I got from last hour is the vast majority of the kids actually didn't want to see their most recent test because the vast majority of the kids were done with the corrections on that. The vast majority of the kids wanted to see their older test because they hadn't had a chance to do corrections on that. So I want to ask you, so listen up. In your hour, I guess that's all we need for the video for today. And then we're going to do the corrections for the rest of the hour. And the assignment is to just basically finish the worksheet. You already did problems 5, 6, 9, and 10 on that. You should just finish those up. There is going to be a Dropbox. I haven't posted the Dropbox yet, but there's going to be a Dropbox to drop the one worksheet in for the last 2 days. Almost guaranteed that one goes in the grade book because it's 2 days worth of homework. So do it. And then the test is tomorrow. All right. That's all I got for the video for today.